Well, hello. As you know, our aeroplane is grounded and it's all because of engine trouble. And basically what we're looking at on this table in front of us is Oscar Romeo's knackered engine, pretty much. Dean Chamberlain is from Nicholson McLaren and his company are going to be overhauling the engine for us. It's in a pretty bad way, isn't it?
It is. It's typical, but a bad way, yes.
What's wrong with it?
The main failing really was the camshaft and the tappet bodies.
So this is the camshaft.
Yeah, we've got the camshaft here. You get a typical lobe, sort of looks like that sort of size. This one, the cam lobe's worn quite sort of aggressively.
So that's very different, isn't it?
It is. It's lost about half of its meat. So
and it's just been ground down, basically.
Just been ground down. And what it does is the tappet bodies are hardened, and through corrosion and wear, that they just chew and eat the camshaft, and they wear each other apart. They sort of run together like this.
Show me where this sits in the crank. This is the crankcase,
This is the crankcase.
Yeah.
So you've got two crankcase halves. So I'll just put the tappet body, typically sits into a tappet body bore, and then the camshaft sits in there.
So where the top of this tappet body is corroded, that's what's wearing down the cam lobe?
It is,
right.
Yes.
And it's corroded because of environmental conditions?
Normally for environmental conditions. Obviously we're in a damp environment. The camshaft's at the top of the engine, so the oil drains down. If they're left for a long time, sort of long period of time, it tends to sort of go dry. So when it starts up, it's got a little bit of corrosion on it, and the metal-to-metal contact just wears.
What's the consequence of that?
So consequence of the valve, obviously as it goes round, the valve, that's cam lobe is opening the valves via the tappet body and closing it. So when it goes around, you're not going to get the full lift of that valve. So you're going to get a small charge into your cylinder, not giving you as much power as what you should normally have on a good lobe.
We weren't picking up any metal in the filters or anything like that, but clearly metal has been lost here. Where's it gone?
A lot of the metal tends to come off and it ends up in sort of into the piston skirts. So it sort of gets ground off, splashes straight, because that's above, right above the piston there, and it just goes straight into the skirt of the piston. You can see all these metal flakes. So majority of it, probably about 80-90%, will end up in the piston.
What, embedded in it?
It's embedded. You see the little dots, and that's typically where it lands. So when the guys are checking the filter, they're checking it, but probably only about 10% of that metal's got through into the filter. The rest of it lands up in here, and that causes this scoring, and say the indents in the piston, because that's all the steel parts in the aluminium piston skirt. Some are a lot worse than others. That's quite a bad one. Again, that one you can see all the sparkly parts in there, and the scoring where that scored the piston, where it's been sort of grinding into the cylinder barrel.
And I mean, over what period will this have been happening then, do you think?
Typically, from the moment it goes through the case hardening to now, it's normally around 50 hours.
So very quickly
It
then,
is.
this has all occurred.
Yeah, once
since
it
its
goes
last
through, I mean, you
lifting.
get some tappet bodies. This is a typical normal tappet body at life. And it's just got a couple of little bits of corrosion, a couple of little bits of speck. It's just starting to go. But as I say, from there to that one there, it's 50 hours, and that's it. And that's a lot of metal to come off.
Basically, everything we see here needs work or replacement. All of this needs replacing.
It does, exactly. You've got, obviously, your camshaft and tappet bodies. They're mandatory. We would have replaced those anyhow on any overhaul. We do see this at part life where they've done it, and quite often we get an engine in for metal contamination. Or people, typical thing a pilot knows is the engine's a bit lethargic. You know, taking off takes a little bit longer, especially when loaded up. But also with your engine, we see this probably about 1 in 10 is you've got the fretting here, so you've got this roughness around here. And these are on the bearing saddles. So your crankshaft will lie down the middle here, and the crankcases are bolted together, and that's the heart of the engine really. And what happens is over the time they just slowly move. If someone's had cylinder work and the cylinders haven't been put on and torqued up correctly, or it's had a shock load midlife and it's been apart, sometimes you find that these two halves don't quite match up where they should have been originally, and they move ever so slightly. And as they start moving, that relieves the torque, and an engineer will tighten up because he's doing nothing wrong, and then that will relieve, starts this bit of movement, and they are the two bits of metal transferring this blackness from one half to the other. And eventually we find the bearings can start moving in the crankcase. It's got some evidence of here with some dent marks there where the bearings have been moving and chattering in the case. And after that, really extreme cases, we've had it where people have stopped to get fuel after maintenance, and they find when the engine's hot that it's tight. And the reason it's tight is because this is, obviously that bore, as the more it's tightened up, that bore is shrinking each time, and the crank bearings nip up on the crankshaft.
So what's going to happen to the case then?
So we'll have to send this off to the States. There's only a couple of companies that have got approval to do this with the ARSA approval. What they would do is we send it off, they skim the whole crankcase. They take a fine amount of material off of each half, and then what they do is they rebore it. So they, obviously these are now oval, so they rebore the crankshaft bore and the camshaft line bores to bring them back to new part limits. While it's there, this crankcase we always get out of the overhaul shop that we use to bring up to the latest spec, and that is that they put dowels into each one of these bolt areas. So that's another way of holding the case from moving, and it stops and eliminates that fretting from happening again.
So this is the crankshaft, and can we use that as well, or is that worn out too?
Unfortunately, this one fails a mandatory Lycoming service bulletin.
Oh dear. Right, show me, what's the problem?
So yeah, it's service bulletin 505, and what it states is that in the internal bore in here, that there's no corrosion. We can bore it out to remove that corrosion up to a maximum size of 1 inch 910 thou. Unfortunately, yours has already been taken out to nearly that size already. We've taken out as far as you can, but there's still the pitting there, so evidently it fails.
So it's these little...
It's all the little
dark
dots.
dots
Exactly, yeah, that's all the corrosion pitting all the way through. As you can see, some of it's quite bad around this side. And that corrosion goes, what we can see here, but it actually goes down about 2 inches.
And that is dangerous, really, isn't it?
It is, because obviously that's then, like Omen brought the service bulletin out, because obviously the prop flange, there's only a certain thickness there that's holding that propeller on with that flange. And if that's corroded, then obviously that can make a point that it must come off at some point.
So this is going to be a big bill for our group now, more than we'd originally budgeted for, so not good news. Well, look, thanks for showing me around this. We'll now go and have a look around the rest of the shop and see some of the other work that's going on some of the other engines.
Okay, John, no problem.
So we've come to the engine stripping bay, and Luke is working on an engine sort of similar to ours. And this is kind of the first stage in the process when it comes to the workshop, is that right?
Yes, that's correct, yeah. What we'll do is we'll get the engine in, we mount it on the frames here, we photograph it and log all the part numbers and serial numbers of that engine, and then slowly Luke will carry on and strip the engine, so every nut, bolt and washer will come off that engine.
And he's got a trolley here, and each engine has a trolley.
That's correct.
With unserviceable parts on the bottom.
Yep.
And then all the other parts there, and everything's catalogued.
Everything's catalogued. We have a work page, about a 45-page work pack, and that follows the engine all the way through. And in that work pack, Luke has noted every part that's come in with the engine. He's noted all the serialised items that have come in. As I say, we've photographed everything. And those photographs and work pack will follow the engine all the way through to when it goes out the door.
And how long will the process of stripping down, just this bit, take?
This bit here, typically a 4-cylinder takes, Luke, between sort of 6 to 8 hours to completely strip
a day's
it.
work, basically.
Yeah.
Now, one thing that people have asked is, you know, if your engine reaches the end of its life, why do you overhaul it? Why don't you just get a new one or a replacement one?
Typically, if you went to buy a new one, they're awfully expensive to buy 100% new parts on an engine. Obviously, you'd overhaul it, but a lot of the parts can stay in that engine. You know, we're measuring them, we're crack testing them, we're making sure they're serviceable to go back in and in the right tolerances.
So it's cheaper?
It's
generally?
a lot cheaper to have it overhauled.
And presumably more environmentally friendly because you're recycling parts.
Exactly, yeah, because you're reusing a lot of quite heavy parts in that engine.
And once an engine has been overhauled and checked and, you know, make sure it's to the right specifications and so on, I mean, is it as good as new then?
It is as good as new. It's as good, if not, I'd say better than a factory engine, but I would say that, going out the door. You know, we've brought it up to the latest AD service bulletins, it's been built to new part limits, and it'll be a good engine for a good 2,000 hours. Once the engine's been stripped, it comes through into the cleaning bays. So here, every part of the engine, as you can see, is all laid out, and it'll all be cleaned thoroughly. So there's no oil, no grease, and no carbon left on it, so it can be inspected correctly. Mike will get all the parts, just remove the final O-rings, etc. We have a big carbon tank that will take all the degreasant and takes the paint, etc. off. And we've got a big hot wash over there. It's almost like your home dishwasher, really. And that rotates and jet washes and cleans every single component we've got.
So we've come into the NDT area, which I presume stands for non-destructive testing. and they've got these big baths of dye, and also this rather curious looking device that ought to really be in my science lab at school, but we'll ask Matt, who is about to do one of the tests here. What are you testing first of all?
So we're testing aluminium or anything non-ferrous with dye penetrant, and we dip these in here and we allow them a dwell time of 30 minutes to sit in the dye. If there's any cracks in it, the crack will absorb the dye into the crack, and then we go over there and wash them off. Any excess dye will be washed off, and the dye that's been taken into the crack will remain there, and then we put it in the oven to dry it off and into the powder to develop the crack.
Okay, we've been thrust into darkness, and we've got I think a UV light here. We've rushed this through so that Matt can show us basically what happens. This is the part that we saw dipped in the dye earlier, and you've cleaned it up. You've put some talc on it.
Yeah, it's sort of like that. So you put it in the oven after you've washed it off to dry the outside. Any dye that's in the crack will remain in there. You put it in the powder, which is on a cycle, which coats a part in powder, and then the powder through capillary action, it draws the dye out of the crack, allowing you to see it on the product.
So we can see where it's shining up there. Are those sort of pit marks in there?
Yeah, that's just where sort of the material's porous or any sort of porosity.
And if the part has got a crack in it, it'll be pretty obvious.
Yeah, it'll glow bright green.
And you test all the engine parts like this?
Yes.
And how long will that take to do?
Depends on the engine size, between 6 and 8 hours.
I'm now starting to see why an engine overhaul costs as much as it does. Yeah, a lot of work. So this is the contraption that you use to check cracks on ferrous material.
Yes, that's correct.
And you've got a conrod here, which you're going to test now. I mean, what is this machine called?
This is a Magnaflux machine for magnetic particle inspection. So we put it between the heads, charge it up with electricity, which creates a magnetic field, and cover it in a paraffin solution with magnetic particles in it with a fluorescent coating, and they'll get drawn into any cracks or defects on the material. So these two obviously are the heads of the machine. You put an electronic current through the part, which creates a magnetic field to show us any defects in the part.
Oh, he's going to turn the lights out again. Okay. I need to adjust the camera. Okay.
Well, I'll just try and get it ready.
Alright, here, liquid. Oh, I don't know what that is. But,
Paraffin, that is. Okay, so we put the parts between the heads, and depending on the part, we charge it to a certain amperage. That puts a current through the part. We then cover it in a paraffin solution full of magnetic particles, which are coated in like a paint that fluoresces. Wherever there's a flaw in the part, the particles are drawn to that flaw, and will sit in that crack, showing us the defect.
You seeing anything?
Not as yet. So this is the part covered in the paraffin, and any defects will glow up bright green. You're always going to get a little bit of background over it, like so, but any cracks or porosity will show up bright green, almost like them edges there.
Yeah.
And then after you finish testing the part, you then have to demagnetise it, which will be done through this. But we won't bother putting that thing in because that's going to ruin it.
It's going to blow. It's going to blow my camera up. Right. Okay. We won't do that bit. Thanks, Matt.
That's all right.
Cheers, mate.
Well, Dean, thanks for showing me around the facility.
problem.
It's great to see the engine and understand exactly what's gone on, what's wrong with it, what's needed. and you invite customers to come in and see their engines in this
We
state,
do
don't
always,
you?
yeah. It's a good time to come in and have a look at the engine.
And to see the whole process really helps us understand what you're going to be doing. I'd like to come back if possible when you're at the stage of rebuilding and testing.
More than welcome.
Perhaps that would be great. And how long does it take generally for an engine overhaul? And what, in terms of our engine, which may be a slightly more complex overhaul, what sort of timelines are we talking?
A standard overhaul is normally sort of 3 to 4 weeks from the time we receive it to the time it's done. Unfortunately, yours, because it needs a crankcase repair, it's going to add another 4 weeks to that. So we're looking at nearly 2 months to have it done from start to finish.
Yeah, it's going to be the new year, isn't it?
It is, yeah, Christmas, New Year.
Dean, thank you very much. Okay. I hope that's answered a lot of your questions. I know many of my viewers have been asking some extremely detailed questions. This is not my field. I fly the aeroplanes. I don't know how their engines work, and clearly a lot of you do. So hopefully that's answered some of your questions about what's gone wrong with our engine, why it's come in for an overhaul now, and we will be charting this process as we go on over the next few weeks. And as Dean says, he's happy for me to come back and see the engine being rebuilt and tested, hopefully, so we'll be doing that. Make sure you subscribe to the channel, sign up for the newsletter on my website as well. Thanks for watching.